Good morning, friends. We'll see theory first, small, because theory is most important thing to follow all the calculations. We go theory first. For owner user, inspection organization, owner user organization responsibility. An owner user of pressure vessels shall exercise control of the vessel and pressure relief device inspection program, inspection frequencies and maintenance, and is responsible for the function of an authorized inspection agency in accordance with the provisions of this code. The owner user inspection organization shall also control activities relating to rating, repair, alteration, and engineering assessment of the pressure vessels and relief devices. Owner user system and procedures. Owner user organization is responsible for developing, documenting, implementing, executing, and assessing pressure vessel pressure relieving device inspection system and inspection repair system and procedures that meet the requirement of this inspection code. So quality assurance system, inspection system will follow these things. Organization and reporting structure for inspection personnel. Documenting and inspecting the QA procedures. Documenting and reporting inspection and test result. Developing and documenting inspection plans. Developing and documenting risk-based assessment applied to inspection activities. Establishing and documenting the appropriate inspection intervals. Corrective action and inspection and test results, internal auditing and compliance with the QS inspection manual. Review and approval of drawing, design, calculation, engineering assessment, and specification for repairs, alteration, and rating. Organization and reporting structure for inspection personnel. Documenting of inspection and QA procedures. Documenting and reporting inspection and test result. Documenting, developing and documenting inspection plans. Developing, documenting risk-based assessment applied to inspection activities. Establishing and documenting the appropriate inspection intervals. Corrective action for inspection and test results. Internal auditing for compliance with QA inspection manual. Review and approval of drawing, design calculations, engineering assessment, and specification for repair, alteration, re-rating. Ensuring that all jurisdictional requirements for pressure vessel inspection, repairs, alteration, and re-rating are continuously met. Reporting to inspector any process changes or other conditions that could affect pressure vessel integrity. Training requirement for inspection personnel regarding inspection tools, techniques, and technical knowledge base. Controls necessary so that only qualified welders and procedures are used for all repair and alterations. Controls necessary so that all repairs and alterations are performed in accordance with this inspection code and acceptable specifications. Controls necessary so that only qualified NDE personnel and procedures are utilized. Controls necessary so that only material conforming to the applicable construction code and utilized for repairs and alterations. Controls necessary so that all inspection measurement NDE and testing equipment are properly maintained and calibrated. Controls necessary so that the work of the contract inspection or repair organization meet the same inspection requirements as the owner user organization. Internal auditing requirements for QC system for pressure relieving devices. Control necessary to ensure that inspectors have the visual acuity necessary to perform their assigned inspection tasks. Management shall have an appropriate requirement and work process to ensure that Inspectors have an annual vision test to ensure that they are capable of reading standard J1 letters on standard jagged test type charts for near vision. Management of change MOC. The owner user is responsible for implementing and execution of an effective MOC process that reviews and controls changes to the process and to the hardware. An effective MOC review process is vital to the success of any pressure vessel integrity management program, as it allows the inspection group to be able to address issues concerning the adequacy of pressure equipment design and current condition for the proposed changes and anticipated changes in the corrosion and other type of damage, and to update the inspection plan and records to account for those changes. The inspection group shall be involved in the approval process and changes that may affect pressure vessel integrity, operating windows, IOW. The owner users should implement and maintain the effective program for creating, establishing, and monitoring integrity operating windows. IOWs are implemented to avoid process parameters exceedance that may have an unanticipated impact on pressure equipment integrity. Future inspection plans intervals have historically been based on the prior measured corrosion rates resulting from past operating conditions. Without the effective IOW and process control program, there is often no warning of changing of operating conditions that could affect the integrity of the equipment or validity of the current inspection plan. Deviation from the changes or of trends within the established IOW at limits should be brought to the attention of inspection engineering personnel, should they may modify or create new inspection plans depending upon the seriousness of the accidents. IOW should be established for proceeding process parameters, both physical and chemical, that could impact equipment integrity if not properly controlled. Examples of process parameters include temperature, pressure, fluid velocities, pH, flow rates, chemical and water injection rates, level of corrosive constituents, chemical composition, etc. IOW for key process parameters may have both upper and lower limit established as needed. Particular attention to monitoring IOW should also be provided during startup, shutdown, and significant process of upsets. See API 584 for more information on issues that may assist in the development of an IOW program. What are the activities before welding? 3 options correct. Drag and drop. Engineer. Responsibility and the approvals. The pressure vessel engineer is responsible for the owner user for activities involving design, engineering, review, analysis, or evaluation of pressure vessel and pressure relieving devices as specified in the inspection code. The repair organization. All repair and alterations shall be performed by qualified repair organization. Repair organization is responsible to the owner user and shall provide the material, equipment, QC, and workmanship that is necessary to maintain and repair the vessel or vessel relieving devices in accordance with the requirement of inspection code. Inspector. The inspector is responsible to the owner user to assure that the inspection of NDT repairs and pressure testing activities meet API 510 code requirements. The inspector shall be directly involved in the inspection activities, especially visual inspection. Most cases will require field activities to ensure that procedures and inspection plans are followed, may be assisted in performing inspection by other properly trained and qualified individuals who are not inspectors, examiners, and operating or maintenance personnel, however. All ND results shall be evaluated and accepted by the inspector, who will then make appropriate recommendation for repair, replacement, or fitness of the continued service. Inspector shall be certified in accordance with the provision of Annex B. The inspector can be an employee of the owner user or be a contractor acceptable to the owner user. Examiner. The examiner shall perform NDE in accordance with job requirement NDE procedure, the owner user specification. The examiner doesn't need API 510 inspector certification and doesn't need to be an employee of the owner user. The examiner doesn't need to be the trained and competent in the NDE procedure being used and may be required by the owner user to prove competency in holding certification in those procedures. Examples of certification that may require include SNDTC 1A, SNDCP 189, CG, SB, AWS, QC1. Inspectors conducting their own examination with ND techniques shall also be appropriately qualified in accordance with owner user requirements. The examiner employer shall maintain certification records of the examiner employed, including dates and results of the personal qualification. These records shall be available to the inspector, who is responsible to the owner user to determine all ND examinations. Examiners are properly qualified for the work they perform. Other personnel. Operating, maintenance, engineering, process and mechanical or other personnel who have special knowledge or expertise related to particular pressure vessel shall be responsible for timely notification to the inspector or engineer potential issues that may affect vessel integrity, such as following: any action that requires MOC operations outside defined IOW, changes in source of feedback and other process fluids that could increase process related corrosion rates, or introduce new damage mechanisms, vessel failures, repairs action conducted, and failure analysis reports. Cleaning and decontamination methods used, or other maintenance procedures that could affect pressure vessel integrity. Reports of experience that may come to their attention that other plants have experienced similar or same service pressure vessel failures. Any unusual conditions that may develop: noises, leaks, vibration, movement, insulation damage, external vessel deterioration, support structure deterioration, significant bolting corrosion, etc. Any engineering evaluation, including FFS assessment, that might require current or future action to maintain mechanical integrity until next inspection. Inspection, organization, and audit. Organization audits. Each owner user organization should be audited periodically to determine if the authorized inspection agency is meeting the requirements of the inspection code. The audit team should consist of people experienced and competent in the application of the code. The audit team should typically be from another owner user's plant site or central office, or from the third party organization experienced and competent in refining and other or petrochemical process plant inspection programs, or combination of third party and other owner user sites. However, periodic self auditing by those directly involved in the site inspection organization is also recommended. The audit team should determine in general whether requirements and principles of the inspection code are being met. Owner user responsibilities are being properly discharged. Documented inspection plans are in place for covered pressure vessels. Intervals and extent of inspections are adequate for covered pressure vessels. General types of inspections and surveillance are being adequately applied. Inspection data analysis, evaluation, recording are adequate. Repair, rating, alteration, and engineering assessment comply with this code. The owner user should receive a report of audit team's findings. The non-conformance are found, the owner user authorized inspection agency shall take the necessary corrective actions. Each organization needs to establish a system for tackling and completion of corrective action generated from audit finding. The resolution of the audit findings should be made available to the audit team for review. This information should also be reviewed during subsequent audits, inspection, examination, and pressure testing practices. Inspection plans. Inspection plans shall be established for an all pressure vessel, pressure relieving device with the scope of this code. Development of an inspection plan. The inspection plan shall be developed by the inspector and the engineer. The corrosion specialist shall be consulted when needed, designate potential damage to the mechanism and specific location where damage mechanism may occur. The inspection plan is developed from the analysis of several sources of data. Inspection shall evaluate based on present potential type damage mechanism. The methods and extent of any shall be evaluated to assure that the specific techniques can adequately identify the damage mechanism, the extent and severity of the damage, type of damage, rate of damage progression. Tolerance of the equipment to the type of damage, probability of NDE method, identify the damage, maximum interval as defined as the code of standards, codes and standards, extent of previous examination, recent operating history, including IOW accidents, MOC records that may impact inspection plans, and RBI assessment where available. The inspection plans shall developed using most appropriate sources. Inspection code inspection plans shall be reviewed and amended as needed when variables that may impact damage mechanism and or deterioration rates are identified, such as those contained in inspection reports or MOC document. When to amend inspection plan after shutdown, after increase the damage rate, after completion the activity, it is minimum content of the inspection plan. The inspection plan shall contain the inspection task and schedule required to monitor damage mechanism and assure the mechanical integrity of the equipment, pressure vessel, or pressure relieving device. Define the types of inspection needed. The external, internal, external. Identify the next inspection date of the each inspection type. Describe the inspection and ND technique. Describe the external and location of the inspection and ND. Describe the surface cleaning requirements needed for inspection and examination. Determine the requirement of any needed pressure test. Types of test pressure, duration, and describe any previously planned repairs. Generic inspection plans based on industry standard and practice may be used. The inspection plan may or may not exist in a single document. However, the contents of the plan should be readily accessible from inspection data system. Describing the type of damage, anticipated experience of the equipment, defining the location of the damage, defining any special assessed requirements, risk-based inspection RBI. Assessment determine risk by combining the possibility and consequences of the equipment failure. When another user chooses to conduct RBI assessment, it shall include systematic evaluation of both the probability of failure and the consequence of failure in accordance with API 580. API 581 details of RBI methodology that has all of the key elements defined in API 580. Section 1 is 1 into 1 into 1 is to 1 is to 1, identifying the evaluating potential damage mechanism, current equipment condition, effectiveness of the past inspection, important step in assessing the probability of a pressure vessel failure, identifying and evaluating the process fluids, potential injuries, environmental damage, and equipment downtime are important steps in assessing the consequences of a pressure vessel failure. Identifying IOW for key process variables is useful adjunct to RBI, as well as any other method, planning and scheduling inspections. Probability assessment. The probability assessment shall be based on all forms of damage that could reasonably be expected to affect a vessel in any particular service. Examples of those damage mechanisms include internal or external metal loss from localized or general corrosion, all forms of cracking, and any other form of metallurgical corrosion or mechanical damage, fatigue, embrittlement, creep, etc. Additional the effectiveness of the inspection practice. Practices, tools, and techniques used for finding the potential damage mechanism shall be evaluated. All factors that should be considered in probability assessment include appropriateness of the material construction, vessel design, condition relative to operating condition, appropriateness of the design codes, standard utilized, effectiveness of the corrosion monitoring program, the quality of maintenance, and the inspection QQC program, both the pressure retaining and structural requirements and operating conditions, both past and projected equipment failure data will also be important information for the assessment. Stop here.